Hello everybody, Chickaboom here, and today we are going to take a look at Universe Sandbox. This is a very fun game. Basically, if you wanted to throw planets at another planet or whatever you wanted to do with space, you could basically do it with this or its sequel, which I can't get because I haven't got enough money. Anyway, you have loads of different simulations here. For example, solar system. You could probably guess, loads of solar system. So you have Sun, Mercury, Venus, Earth, Mars, the asteroid belt, Jupiter, Saturn, Neptune, Uranus, and Pluto. Speaking of which, you apparently shouldn't be there. Anyway, yeah, you could basically do whatever you want. You just double click something, like we can focus on Earth, and we can move its inclination. So now, it's not much of a circular orbit as it is a 3D. It's now almost perfectly spinning round like that. Kind of awesome, isn't it? Anyway, what else can you do? Well, you can orbit, make it orbit something else. I'm not sure what else you can. Let's say Jupiter. You are now an error. Hang on. Okay, we're back. Anyway, yeah, you have the Trans-Neptunian things. You have Quadar series, which has a very strange orbit. Jupiter, which you can also focus on. One cool thing that I've noticed today, thanks to Anthony, is you can change the color. So I can now make this a very extremely dark red, which is kind of cool. If you come up here, you can just reset everything. Reopen the simulation. One thing we can do over here is change the color mode, so we can have the acceleration. I'm not sure what that actually does, but still. The velocity, so it shows everything by its velocity. That's staying still. All these are moving at different speeds, and the slower they're moving, the closer to pink they go. For example, Pluto is very purpley. It also makes it kind of look kind of cool from a distance because you have all these different colors. But yes, now to the destruction anyway. You can have a new simulation where you just literally have. Hold on. Create empty simulation. There you go. Yeah, you have nothing, and you can make anything. First of all, let's put a big fat sun. Where's Beetlejuice when you need him? Or we can have Canis Majora. This is the biggest, yet the least dense of all stars. If I can find the Eta Carinae, I think that's how you pronounce it. It's one of the smallest, but it's one of the densest. Notice the density over here is that, but the density of that is much less. But yeah, anyway, one cool thing you can do, click chart mode, and you can put it into orders. So if I wanted to just pop it there, grab another load of stuff like teapots, pop a teapot around you. No, I want to. Well, let's just pause it by pressing space. Make you orbit make a dice orbit, make a monolith orbit, and a ring orbit. Oh, and a bowling ball. Now, if we go to chart mode, we can see, if we go to mass, the biggest mass is Eta Carinae, because you can see the mass here, 110 suns, and that's just 20 suns. And that sun is, by the way, it's the size of our sun. So that's 20 times the size of our sun. That's 100 times the size of our sun in mass. The diameter, AU, is the distance from... What the hell? Why have you changed? Why have you changed, Canis Majoris? Anyway, AU means the distance from Earth to the sun, or the sun to Earth. So that is 18 times the size. Whilst Eta Carinae is just 1. So it's about the same distance all the way around it. And then you just have these. Oh, you just have, like, tiny dice. And it's actually quite similar. It's 1.4 centimeters, so it is very, very small when you compare it to something like that. But yeah, if we go to mass diameter, it will now, of course, be this is the biggest. Velocity, apparently Eta is also. Temperature versus luminosity, mass versus diameter, radius versus density. The name, so it goes in order of alphabetical order, I think. Distance, probably distance from us. Well, of course, the bowling ball is going to be the least. Random order, so you could just click that and it just goes into any random order. Original, I am not sure what that is. I think it's how it was originally. Anyway, put it onto density, and you can see that Canis Majoris is apparently actually bigger in density. Density. Yeah, I'm not sure how that works. But anyway, if you wanted to keep them going, you can just press make live. And that is now apparently in real time, probably. No, that's real time. And as you can see, if we zoom in on here, on something. Oh, friggin' hell. Focus on you. You are now circling around that, which is going into the... Oh, hello. A landing craft is apparently heading towards that. Let's turn you up a bit. So let's go 24 hours per second. Boop. Yeah, it's kind of going quite slow. Oh, something's gone a bit weird. Exit surface view. But yeah, that's a monolith. And there's a landing craft apparently going to it. But yeah, you can see how big things are. I mean, wow. The cool thing is, you can, if you wanted to, let's reset the simulation. If we wanted to make a giant collection of them, we can grab wherever Beetlejuice is. Where is Beetlejuice? Well, Bernard Star, that's actually one of the densest. So we'll pop you there. Beetlejuice, here we are. Beetlejuice. And just in comparison, that's our sun. And that's the Earth. You could put it in orbit of them, or I can put it in orbit of Beetlejuice. And now if I go into chart mode, of course, the largest mass will be Beetlejuice, but the density is actually quite surprising, I believe. Because that has a very low density, while Bernard Star should be the highest. There it is. St. Bernard's well, Bernard's star is the densest out of all of them. Yet, yeah, because the mass is 0.16 suns. So it's 0.16 of that. One Earth, that's because one sun, focus on that. And look how big Beetlejuice is compared to that. Kind of amazing, isn't it? Let's put you back onto density. Now, if we just go original, or just put you on any random one, we can now go over to here and get where is it? Canis Majora, and you can see just a little bit bigger. And where by that I mean, of course, yeah. Anyway, let's grab this. Let's grab you and go 1 month per second, or 30.4 days, and see what happens when we hit that. You should slowly be starting to head towards. Oh, make live. There you go. That is now going to head towards you, but you are also going to head towards. Oh, lovely destruction. The thing is about this one is doesn't know how to render collisions, even though the sequel does, which I really want to do. Which hint, I want to do that as a plain video. Yeah, because of that, it just pings off. Ping, 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 ping. For example, if we just sped you up a bit, see? Just pings off. But we can go reverse you, Bernard Star, turn you right up into 1,000 or 10,000 kilometers per second, and you are now going like that. You are now traveling the speed of almost a third, well, actually a 15th the speed of light. I believe it's a 15th. Anyway, we can make it travel the speed of light, like so. Speaking of which, I'm going to show you something in a minute to do with that. And as you can see, traveling at the speed of light means it will just go. Keep going, never turn back, Bernard Star. We can now put you to 0, and it in fact increases in size, but it's going to of course head for that. Let's make you 0 as well, so you also head to that. In fact, let's just, you're very slowly heading towards there, so let's increase everything. Look at that. They are not going to collide at all, are they? Bernard Star, very, very small. And of course, Earth, nope, you are now heading back. What else? Oh, looks like the other Earth is gone. But yeah. Let's have a look at something else I want to show you, which is very cool. Very, very cool. If I go back here, you see, I believe it's somewhere here. Click that. You can have a light pulse. That basically goes at the speed of light. Make sure this is in real time. This is in real time, second per second. This is how fast light goes. That is the pulse of light. It will take 8 minutes, about 8 minutes to get to there. But yeah, we can't really wait for that, so let's actually put 1 minute, a second. So, you can see it takes about a minute to go from there. We can click the sun again. Wait until it's a nice little thing at the top left. So we can see 9, 10, go. 3, 4 seconds to get to Mercury, 6 to get to Venus, and 8 to get to Earth. And then it just continues. But just to show you what it is within a year, 1 year, a light year. Oh. Yeah, I think I should do that. Okay, so 1 day, we should have you. 1 millisecond is 1 year. I haven't changed anything, so I don't know why it's doing that. I like the way it's all the rocky planets are going a bit weird, but all the gas giants and all these Orcus and Pluto and things like that, all of these are fine. It's just pew, and it keeps being pulled. Look, it goes back out, back in, out, back in. Where's Venus gone? Venus, you're going for a second bloody route again, aren't you? Anyway, click the sun and hit light pulse. Where's it gone? It's way out there. In 1 year. Yeah, light travels quite fast. If we reset it again, because lag, we can make the sun a black hole and see what happens there. So, the sun, you are now a black hole. And so everything should slowly... You are now a black hole, so why aren't you... Why... 1 frame is 1 day. And we are currently... I have no idea how many frames per minute we are running at. The G's, I want to mess around with this really, really badly. Straight the way down. So that now is just... They're all just going to go. No more planets needed. Actually, you know what? Yeah, I think I need planets. So, could you please all very, 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 very hurriedly come back here? Just look at that wonderful pattern we have created in the sky. Let's actually have a look at other ones we can do. We can have the Earth and the Moon. And then we'll just orbit Earth. Or we can just, you know, screw around with the Earth a bit by moving it. We could completely screw up the Moon's gravitational pull by doing that. You are now going to keep continuing that way. So that's why I'm going to pop you there. And zoom in. Or not. Screw you. You are going to smash into the Earth. Oh, there we go. Catapulted. And you're back in orbit, aren't you? See? This is why it's we don't have a problem with any sort of moon crashing into the Earth. Because if anyone tries to move the Earth to be in the path of the moon will just sort itself out. Simple. Even though I am kind of... Yeah, it's kind of spinning on its axis, isn't it? So if we can just sort that out, please. That would be great. Hold on. Actually, hold on. Oh, you mother piece of... There we go. The pole. Oh, come on. You. No, you. Fudge. Ah, screw it. We can now, what we can do here is we could just go pop. And it completely smashes in. First of all, let's restart the simulation. So that's happening 3 hours every second. if we happen in real time, I am talking to you from about here. You can see my mouse. About there. Oh, fudge. What the hell is this landing thing? I want to get rid of it. But yeah, this is happening in real time. So if we got the moon and we said, you don't move anymore, you are going to head straight for the earth, and we will watch you do it, we would have quite a while to worry. This is an hour a second. An hour a second. Yeah, you can see the slight movement. 1 day a second. Now that's what I'm talking about. You can see it spinning, and it's completely pinged off because of the whole thing. But yeah, this is the first episode in this series, so if you want to see any more about this, then check it out. This is very, very cheap. Very, very, very cheap. I can't remember the price of it, but I will probably put a link to it in the description. It's on Steam. I really like this game because you can do things like that. You wanna see our galaxies? That's our galaxy, right there. And Canis Major Dwarf. That's the Milky Way compared to every other thing. If we put it into bar graph mode, you can see that the Andromeda Galaxy is much, much heavier. Density, however, and it's all of these smaller ones. Like the sun. Are you kidding me? The sun is denser than entire galaxies. No. Velocity, and of course it's going to be the sun as well. Name, Andromeda is first, of course, and the last is Melot. Distance, of course, I think it's from us outwards. So, yeah. Make live, you will now just move around 3,000 years a frame. Yay. How about we go 400 centuries. 400 centuries. 40,000 years. You're just gonna go around like that. But yeah, we can see this floating moons, which basically means all of these moons will find gravitational points and collide together, like you can see over here. Moons, and more moons. I've never seen so many moons. But yeah, moons all around you will just collide together. And then once they've collided together to make little mini planet-like things, they will all collide into one central point, which is kind of cool to watch, because it shows that even when the moons are around, there's literally no escape. And in fact, we're going to just fire friggin' more moons at it by going into here, pressing that launch bodies, selecting the moons, and grabbing our moon. 'Cause screw you. Just a whole line of our moons going boop, kaboom. You can please go in reverse, because I think we all need to see what happens here. There also collision with Jupiter, so that's us colliding with Jupiter, I believe. Jupiter and moons, Neptune and moons, constellations, which is basically a very, very large one, so it may take a bit of time to load. But yeah, all of that is it's just amazing to see. From our sun, Alpha Centauri A, look at it. Pegasus over there, Triangulum over there. and it's all 3D. Ursa Major. It's just, yeah. Nerd out. Anyway, another cool thing you can do is watch galaxies collide. Our galaxy and Andromeda, to be exact. 5,000 years Oh, fudge. Oh. I think we need to reset it because I have no idea what happened there. So it is happening that many years a second, and we are there. That is us. That is shows you how significant we are to the rest of the galaxy. But yeah, this is going to be very fun to watch, and if you want to do it, if you want me to, I can make a real-time series. It will only take about 1 million years. I mean, who wouldn't want to watch two galaxies collide very, very slowly? No years at all. Or we can just go whoop and get you moving again. There you go. Kapoo. And the cool thing is one thing I've learned is when we've all gone and done that, that's our Milky Way. And the Andromeda galaxy is there. No, that's the sun. Andromeda is over here. The cool thing is they'll collect more pieces of dust, like the Andromeda already has, and the Milky Way is doing. And what they'll do is go back again. Fight it out to the death. They'll go back on each other again because of the central points of gravity and basically collide again. And let's just speed it up a little bit. So you can see it collects again, that collects again, and they will basically just collide again. And our sun is there. By now, we would have been screwed because the sun would have exploded. So, technically, that shouldn't be there. But this is just amazing to do. Just to screw around with planets. And, I mean, it's not just all these. You also have open a simulation here. And you can have featured ones. Like, there's one with 2 dice. If you go to community, I believe there is one. Power 2's open simulation, and this basically shows you points from the sun, and that 0 is the point where we are. There, that's about the distance we are, because that is 1 AU, I think. Yeah, here the distance is 1 AU, and it goes all the way up to 10, which is, I believe, way over here, which is 1024 AU. Yeah, it's kind of amazing. I'll do one more, and that will have to be it. So let's go into open. We can have. Where is it? We can have the Death Star orbiting Endor. It's just so hilarious just to see this, because I know a bunch of people in the comments are just gonna nerd out like I have today. Just the Death Star is just now a moon. Wait, that's no moon. People are gonna hate me today, aren't they? Oh well. But yeah, Death Star. We can now go. You know what? This is how it should have gone. The Death Star doesn't move, and so it just slowly heads towards Endor. Even though I could have done it on the lighter side of the planet. And boop. But yeah, I think that's all we're gonna have time for today. So if you liked it, like and subscribe as usual, and yada yada yada. And if you want to see more from this series, please let me know what you want me to review, and if it looks interesting enough and it's what I want, what I like, the sort of games I like, then sure. And as a little thing, I shall show you one more object thing. Explode. Explode, explode, explode. Explode until the... Fuck your frame rate. Fuck your frame rate. Fuck your frame rate. Ah. And that's what happens when Endor completely and utterly explodes. The more you know. So yeah. Oh, that's a bit of lag, isn't it? But yeah. Endor completely being obliterated. Not by the Death Star, but by a god.